Okay, so here's our objective. We're going to build Pascal's triangle in order to complete the binomial theorem. And that's so that we can expand binomials that are raised to a power. So first things first, let's look at Pascal's triangle. And if you look at this, here's Pascal's triangle. Now what I want you to do is take a look at this and see if you can figure out the logic behind this. So notice that it makes a triangle, but how did I get this red 2 right here? How did I get this 3 and this 3, these 4s and these 6s? So what I want you to do is to pause the video right now and see if you could possibly fill in the next row. So what would this next row look like? Okay, so write this in your notes and pause the video and see if you can figure out what this next row would look like. Okay, so I hope that you figured it out, and you can see it makes a triangle with the outside edges. All of these outside edges right here are 1, so you can see that all of these outside edges are 1. So the same thing for this row, this 5th row, it's a 1. And now when I come down here, the logic behind this is to get this next number, I just have to add these two. So 1 and 4 is 5, and due to symmetry, 1 and 4, I get a 5 over here. So the triangle is very symmetrical. 4 and 6, I get a 10, and 6 and 4, I get a 10. Now if you didn't follow that, this is the key to the Pascal's triangle. 1, let's go down all the way, and then to get this number 1 and 1, I add those as 2. 1 and 2, 3, 1 and 2, 3, 1 and 3, 4, 3 and 3, 6, and so on and so forth, all the way down. So that's the logic behind Pascal's triangle. And there's a lot of really great relations and uses that come along with Pascal's triangle, and we'll be exploring those throughout Algebra 2. So now let's look at this. The row over here, we're going to represent as an N. So we're going to use the letter N to represent the row, and we're going to start off at 0. So here's a quick tip. Always start with 0 in Pascal's triangle. So the row starts at 0th row, 1st row, 2nd row, 3rd row, 4th row, and 5th row. Now we're going to have another letter represent the element number. So K is the element number. And again, always start with 0. So let's look at a notation here. So here's a notation that we're going to be using. And let's shorten these. Okay, so I have this notation, N and K. Well, we know that N is the row number and K is the element number. So this is just a way to represent one of these. So I can represent this 4 here in N and K notation. You might also see it in this notation. And so we'll explain both of those really quickly. And also, just so you just for your notes, we'll use this later when we get into probability, but this is also equivalent, and this it's not an explanation point, it's a factorial. But you don't have to know that right now, but this is in the future, you will be using that. So let's cover that back up so it doesn't confuse you. So let's look at an example here. Let's say that we want to represent this 4 right here. Well, in this notation, we're going to say, what's the row number? Well, the row number is 0, 1, 2, 3, 4. So the row number is 4. And the element number, well, remember we start off with 0. So 0, 1, 2, 3. So that means that row 4, element 3, gives us a 4. And that would be equivalent to writing it in this form of my row number 4 and my element 3. We are going to concentrate on this style right here, however. So let's do one more example. We'll do this one in green. Let's say that I want to find out what the element in the 5th row and 3rd element is equal to. So let's come down here and we'll go 0, 1, 2, 3, 4, 5, and I'm going to go over 0, 1, 2, 3. So this 3rd element is 10. Okay, let's look how we apply Pascal's triangle to use the binomial theorem. Okay, so take this down in your notes. The binomial theorem. Well, what is it? The binomial theorem, simply written, is that it can be used to expand binomials that are raised to a power. Well, we already talked about what a binomial is in the last lesson, but remember, a binomial could be something like x plus 2 raised to a power. Well, we can say that to a power of 5. Now, how do I expand this? And we do that using the binomial theorem. Now, we are going to explore the binomial theorem later in the course as well. So right now you won't understand this summation notation, or maybe you remember from Algebra 1. But don't get too hung up on this. This is a binomial theorem. By the end of Algebra 2, you'll be able to read this because we'll have gone over it. But for right now, I just want you to understand the binomial theorem and how simple it can be. So let's have this scaffolding for the binomial theorem. I want you to write this down and let's go over it. So right here we have a binomial raised to an exponent, and we're just going to put that this exponent is some unknown. We'll put n. And now it's going to be equal to, well, we're going to put a blank here, and my first term in this binomial is a, so I'm going to raise a to whatever this highest power is. The second term to 0. And now when we set this up, we'll see that there's a sequence. Now let's put a space in front of each one of the terms. And you can see that we go from my first term, a to the n. The next one is we're going to subtract 1 off of that. Then we subtract 2 off of that. And then so on and so forth until we get a to the 0th power. And now my second variable, b starts off with 0, and then it counts up. It goes b to the first, b squared, b to the n. Okay, let's do an example of this. Okay, here's an example, and we're going to follow this scaffolding right here. So a plus b to the 4th. Well, let's leave a blank here right now. In my first term, we have a, and we're going to put that to the full highest exponent, so that's a to the 4th. And my b value, that's my second one, we're going to start off, that's b to the 0. Now, let's leave another blank here. And I'm going to subtract 1 off my a value, so this becomes a to the 3rd. And now my second term variable gets one of those exponents. So you'll notice that these will always add up to be the highest exponent. So another blank. A, now we're down to 2, we're counting down, b is counting up. Another blank, a to the 1st, b cubed. Now last one, now a is at 0 and b is to the 4th. Okay, now one quick note is, if you remember, anything to the 0th power is equal to 1. We have this note, anything to the 0th power is equal to 1. Therefore, I don't technically have to write these terms right here in. So I could erase those out because we know that anything multiplied by 1, it just stays the same. Okay, now you might be saying, Mr. Phillips, what goes here? What goes here in these blanks? You didn't explain these blanks. Well, I'm going to explain those in 1 second, but I want you to get the scaffolding down. Okay, let's do the scaffolding for this one. So again, it's going to be a blank for right now. We're going to fill in that blank next. My first variable is x, and it goes all the way to the 3rd exponent. Now I'm not going to write the y because we know that's 1. Y to the 0th power. We have a blank. Now I have x squared b to the 1st. And I have a blank. This is x to the 1st power. X is counting down, b is counting up. And the last one, I have x to the 0, so I'm not going to write it, and b cubed. Alright, let's fill in these blanks here. And this is where we need the Pascal's triangle. So let's just copy Pascal's triangle from the previous slide. And now notice that we used n here to represent this exponent. Well, that's n is representing the rows, so all I have to do here is, since this is a 4, come down to the 4th row, and I'm going to plug in these and put them in as coefficients to each one of these terms. So for this one, let's look at, let's do this in green. So it's a to the 4th. So that means I'm going to come down to this 4th row. And notice there's 1, 2, 3, 4, 5 elements in this row. And there's 1, 2, 3, 4, 5 elements here. So all I have to do is plug those in front of each term. And that will give me my expanded form. So here, in simplified, it's a to the 4th and plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the 4th. And that's my expanded polynomial. Alright, well, let's look at now this one, and this one is row 3, or raised to the 3rd exponent, so I just have to come up 1, and then I can fill in all of these, and notice that the first and the last term will always be 1, and then I have a 3 and a 3 here. Okay, let's look at an example, a few examples on how to do these so that you're clear on how to expand these binomials. Okay, here's my first example, and I need to expand this. So let's put my Pascal's triangle over here. Put it up in the corner, and let's expand this. Okay, so I know that I need to. I need to write this out, and it's the 4th row, so I know I'm going to have 1, 2, 3, 4, 5 terms in this. It's always going to be, since we start off at 0, 1 more than the row number. And let's go through and write this out. So the first term is going to be x to my highest exponent, and we'll leave a blank here, plus, we'll leave the blank. Now we have x cubed going to put a parenthesis here, and we have negative 2, and that's to the first power. I'm going to move this down a bit. Now, again, we're going to have a blank here, and now we're at x squared, negative 2 squared, plus x to the first, negative 2 cubed, and we're almost done. We're going to have a blank. I'm not going to write the x because it's x to the 0, and we have negative 2 to the fourth. Alright, so let's use Pascal's triangle now. We're on the fourth row, so let's come over here and fill in these fourth row element numbers. So fourth row, we have a 1, a 4, a 6, a 4, and a 1. Alright, last step here is to simplify. So let's simplify this out, and I'm just going to write my x to the fourth. Now we have plus 4 times negative 2 to the first power. So that gives me a, let's write this in green, when I combine these like terms, a 4 and a negative 2, that gives me negative 8. And I have x cubed. So now I have, let's combine the 6 and the negative 2 squared. Well, negative 2 squared is 4. 4 times 6 is 24. So here I'm going to get plus 24. Let's write that in green. So I have plus 24. And my x is x squared. And now I have plus, and I have 4. Now negative 2 cubed is a negative 8. So I have negative 8 times 4. That gives me a negative 32. And now we have just x. My last one, negative 2 to the fourth. That's negative 2 times negative 2 times negative 2 times negative 2. Well, that gives me positive 16. So my last term is plus 16. 16 times 1 is just 16. Alright, now plus a negative, I can just rewrite that simply as minus 8x cubed plus 24x squared minus 32x plus 16. Now note that when since I had this negative number right here, that I get this alternating negative, positive, negative, positive. And I can also check that my exponents count down 4, 3, 2, 1, 0. So this works. And this is my final answer. Okay, let's look at this question. This one says, doesn't ask you to expand the whole binomial. It just asks to find the coefficient of m squared. So coefficient. Ooh, what's that word? Coefficient. Well, if you remember back, that's the number that comes before the variable. So we're looking for what is the coefficient of m squared. What goes in front of the m squared term in this binomial raised to the 5th power. So let's look at that. Let's do this one in blue. So again, let's paste my Pascal's triangle, and let's start expanding this. So we're going to start expanding it, but you'll see that we won't have to go all the way through. So my first term is m, we'll put that to the 5th, and let's leave a blank here. M to the 5th, and now we have 3 to the 0th power. But remember, I didn't have to write that, so I'm going to erase that. Let's start off with m to the 5th. Now we have plus m to the 4th, 3 to the 1st power, plus m cubed 3 squared plus blank m squared 3 cubed. Now I could keep on going here, but I'm already at my m squared term, so I don't have to go any farther. So this is going to be plus dot dot dot, and we don't need to know this to answer this question. So I have this written out. Now let's come down and note that I'm on my 5th row here. So I'm going to look at my 5th row and fill in these numbers. Well, my first coefficient is always 1, then I have a 5, then I have a 10, and I have a 10, and it keeps on going, but I only need to know this 1. So all we need to know is what's in front, what's the coefficient of this m squared. So let's rearrange this. Let's put the m squared second, the last. And then we have this 10. We're also going to multiply that by 3 cubed. Well, 3 cubed is 3 times 3 times 3. 3 times 3 is 9, times 3 is 27, so we have 27. We still have that times 10. So then my final answer is 10 times 27 is 270 m squared. So find the coefficient of m squared. Well, the coefficient is whatever is in front. So my coefficient is 270. Alright, let's do one final example here. And this last example is find the third term in the expansion of 3u minus 1 to the 4th. So I'm finding the third term. So let's start expanding this out. Again, let's paste my Pascal's triangle. You guys will have this in your notes, so you don't have to constantly keep writing Pascal's triangle. You have it. However, it's fairly easy to reconstruct. So let's put Pascal's triangle down here for right now, and let's start expanding this. So we have 3u minus 1 to the 4th. If you notice right here, 3u, it's not just a single variable. We have this 3 here, so that's going to add a little bit of a trick. So let's try this. We have first our blank, then I'm going to put in parentheses 3u, and it's raised to the 4th power. Now I have plus a blank, and I have 3u to the 3rd power. Notice that I'm putting the 3u in parentheses and I'm raising the whole thing to the 3rd power. Now I have plus, oh, I forgot my second part of that, which is b to the 1st power, plus I have my blank, and I have 3u counting down, so it's squared, and I have negative 1 squared because I'm counting up, and plus dot dot dot. Now note that I don't have to go any farther because this is my first term, my second term, and this is my third term. This whole thing is my third term. So I only need to figure out what this third term is. So let's go through and note that it's the 4th element, or the 4th row. So I'm going to come down here to the 4th row, and let's fill in our Pascal triangle coefficients. So we have 1, 4, and 6. So if I come down here, let's simplify this. I have 6 times 3u quantity squared times negative 1 squared. Okay, so since I have 3u squared, that means that each thing in here gets squared. So when I rewrite this, I can write it as 6 times 3 squared times u squared times negative 1 squared, and that's just 1, so we can just write that off. Negative 1 times negative 1 is 1. So that now we have 6 times 9 times u squared, and I combine those. 6 times 9 is 54 u squared, and that is my final answer. Okay, I hope that this helped, and if you're confused on how to do some of the basics, make sure that you raise your hand, and after you guys get this down, you'll be able to complete these problems fairly easily, but make sure you're trying to see the elegance and how much more efficient it is and how logical it can be. If you start making connections, then that's very powerful. All right, raise your hand if you need help.